All right, so we are graphing polynomials, okay? There's a couple things that we need to know before we get started, and it's mostly definition-wise and maybe abbreviation-wise. I'm going to ask you permission if we can use an abbreviation, okay? So there's a couple things we need to know to begin with. This, and this will help us figure out the end behavior, okay? The leading coefficient, the degree, and the terms will help us figure out the end behavior. So first of all, can I use LC for leading coefficient? Are you guys okay with that? Because those are long words. And to be honest, a lot of you can't spell coefficient. Even though I wrote it on the top of the worksheet, you would still spell it wrong. I love you, though. I love you. Okay? So we're okay with using LC? Okay. So what is the leading coefficient? What does that even mean? What is a coefficient? The numbers in front of the variables, right? Well, then what would a leading coefficient be? The first one. The first one, right? The first one, if what's true. If the exponents are in order, that's exactly right, okay? If the exponents are in order, the leading coefficient is the first one, okay? Now, we don't care so much about the fact that the leading coefficient is -5. What we do care about is that it is negative. Okay, you can put -5 if you want, but the 5 is not the important thing. It's the negative part. Because this is going to tell us the right behavior. The behavior to the right. And I'll make sure you understand what end behavior means in just a second, okay? Degree. What's a degree? We talked about it a little bit last week, but do you remember? So for the record, if you don't remember, I do, and I can tell you what it is, okay? So does anybody remember what a degree is? Highest exponent, okay? So in this particular case, our degree is 4. Now, the possible number of turns is super hard to figure out. What's the degree? 4, subtract 1. Okay, done. 3. The number of turns is always 1 less than degree. Okay, well, what we're going to write. Technically, not always, but it's not something that has to worry us. If it says, if the degree is 4, our number of turns is going to be 3. Okay? Now, end behavior. Can I take a commercial break real quick? Is that okay? Okay. Here's my commercial break. Let's think of a parabola, okay? I don't care what's happening in the middle of the parabola. I care what's happening on the ends. See, if this is the end behavior to the right, and this is the end behavior to the left, do you see that it's rising to the right and rising to the left? It doesn't even matter what my shape looks like, because I don't care about in the middle. I only care about what's happening on the ends. Does that make sense? It could be doing all sorts of weird, crazy stuff in the middle. I do not care about that. I only care about what's happening on the ends. Does that make sense to you, what I'm talking about if I say end behavior? Okay. All right, back to the show. Ready? End behavior. Well, I'm going to come over here in this space right here and just draw a really quick sketch. Now, notice I haven't touched my calculator one time, have I? But because of the leading coefficient and the degrees and the turns, I have a general idea of what it looks like. I know that if it's negative, the leading coefficient is negative, it tells me what's happening to the right. What's happening to the right? It's falling. It's going down because it is negative. If this was positive, what would be happening? It would be going up, right? It's going down. Now, how many turns are there? 3 turns. And what do I mean by a turn? A change of direction. So this is 1 turn. This is 2 turns. This is 3 turns. So now tell me what's happening at the left behavior. It's going down, right? So it's going down to the left and it's going down to the right. And to be honest, that used to be good enough until I started teaching college algebra. Okay? And when I started teaching college algebra, I saw how their textbooks, how their conversations were, and I changed how I taught it in high school. Because all of you weren't going to college, right? But a lot of you are, or at least some of you, right? And I want you prepared for that. You okay with that? Okay? So here's what we're going to write. I'm going to write it in algebra, and then we'll translate it to English. Okay? As x goes to infinity, negative infinity, h of x goes to, as x goes to infinity, h of x goes to. So that's what it looks like in algebra. As x goes to negative infinity, h of x goes to something. As x goes to infinity, h of x goes to something. So here's what it means in English. Okay? As x is going to, what does this mean? Negative infinity. To the left, right? As x is going to the left, what's happening to the function? It's going down. So how do you think we would write that? Negative infinity. That means down. So as x is going to the left, y is going down. Right? The value of the function is the same as saying y, right? Okay? What's this saying? As x is going to the right, because it's going to positive infinity, what's happening to the function? It's going down, so we would also put negative infinity because it is going down. Now, last period they said, so what's the answer? Right? Because usually we get x equals 5 and we circle it and we go on, right? Guys, this is the answer. This whole thing is the answer. We have to know that the leading coefficient is negative. We have to know the degree is 4 so that we can know the terms are 3 so that we can decide on the end behavior. And this is kind of a little sketch that actually helps us with the end behavior, yes? So this whole, like all of our work, quote unquote, our work is the answer. Does that make sense? Okay, so for each problem, for each function that I give you, you're going to know the leading coefficient, the degrees, the terms, and the end behavior, and you're going to have a little sketch over here. Okay, now, I'm going to, as carefully as I can, make sure that you understand what I was talking about the terms a minute ago. Okay, because I said we're going to take the degree and subtract 1, and that'll give us the number of turns. And then I said something like it's not always the number of turns, but just go with me, right? Okay, so what's true about this? Well, first of all, if I graphed this function, is it going to look exactly like this? No, that looks like hills as you're driving like through a valley or something, right? Okay, but it's going to look similar to this. Maybe not the middle, but remember, what did I say about the middle? We don't care about it, right? What we care about is the ends. It could actually just look like this. Or it could look like this. Or something like that, right? The middle doesn't matter. What matters is the ends. No matter what this looks like. And I'm going to grab a calculator and graph it for you so that you can believe me. Okay? Not that you think I lie all the time, but because I usually don't. But you know what I'm saying. So if I add a graph here, I'm going to put in negative 5x raised to the 4th plus 7x raised to the 3rd minus 6x squared plus 9x plus 2. Does this look like this? Does it look like that, though? If I just look at the ends, it does, right? The end behavior is what's important. Okay? Is everybody okay with that? We good? Should we try another one? Okay. Let's do g of x this time. G of x is 7x to the 7th plus 12x to the 5th minus 6x to the 3rd minus 2x minus 18. Okay, so I'm going to go ahead and write down all the stuff that we need. Our leading coefficient, our degree, our terms, and our end behavior. I can even write down this part too, right? As x goes to negative infinity, g of x goes to, and as x goes to positive infinity, g of x goes to. I can write all that stuff down. All right. Does anybody know what the leading coefficient is for this problem? It is 7. So what are we going to write down for leading coefficient? Positive. Okay. Now why is 7 the leading coefficient? It's the first one, and exponents are in decreasing order. That's exactly right. Okay. What is the degree? 7. And how do you know that? It is the highest exponent. Okay. What about the number of turns? 6, because 6 is 1 less than 7. Perfect. Okay. So I look at this, my leading coefficient, and I know that tells me my right behavior. So my positive infinity direction, right down here. Okay. So I know to the right it's rising. I know there's 6 turns. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 turns. Yes? Okay. So as x is going to the left, as we're going this way, what's happening to the value? It's going down. So we say negative infinity, right? Because that's going down. So what's happening as x goes to the right, as x is going this way, to the right, g of x is going where? Up. So what do we write? Positive infinity, right? Up. Or just regular infinity. We could write positive infinity if we want, but we know there's no such thing. It's just going to the right. Got it? Good? Can we do one more? Okay. We'll let it be f of x. Whoa. F of x equals negative 2x to the 4th plus 12x to the 8th plus 17 plus 15x squared. Leading coefficient, degree, turns, and end behavior. As x goes to negative infinity, f of x goes to, as x goes to positive infinity, f of x goes to. Tell me when you're ready. We good? Okay. What's wrong with this problem? So do I have to put it in order to be able to figure this stuff out? Oh, I don't? Okay, what could I do instead? Is my leading coefficient negative 2? No, it's not. Where is the leading coefficient in relationship with a degree? Where's the leading coefficient in relationship with a degree? It's with it, isn't it? Okay, so if we can find the degree, we can also find the leading coefficient, can we? So what's the degree? 8. If this is the leading coefficient, if this is the degree, this is the leading coefficient, isn't it? Okay, so the leading coefficient is positive. It's positive 12, right? A positive. Okay. Turns? 7. All right. This tells me the right behavior. Yes, absolutely, and that's a great question. Okay, leading coefficient always tells me the right behavior. So 7 turns. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 turns. So as x is moving to the left, where's the graph going? Up. So what are we going to write? Yeah, normal infinity. As x is moving to the right, it's moving up, so infinity. Yes? Now, can I show you, I know we just did all the examples, but can I show you a real quick, like a shortcut, maybe? Oh yeah, that would be nice. Okay. Look at this third example that I just gave you, and then the first example I just gave you. Okay? Notice what kind of number the degree is. So, yeah, that's what I want to say. What do I mean by what kind of number? What number is this? 8, and this one is 4, and those are both even numbers, right? What do you notice about the directions of the end behavior? They're the same, right? Both of these are going down, both of these are going up, okay? And the second one I gave you, the degree is odd, and they are going opposite, right? So odd degrees go opposite directions. Odd degrees go opposite, even directions go the same, or even degrees go the same. Will that help a little bit as well? Okay. Do you have any questions? You good?